I'd like to introduce our speaker today, but my talk today is entitled Strange Consistency. Are we good on the camera? Okay. This is actually, I titled this talk Strange Consistency. Some of you know of Carl Messick. He has a blog called Strangely Consistent, which looks like this. Musings about programming Perl 6 and programming Perl 6. So what Carl means by this is that's what this talk is going to be about, what he means by that. What he means, things that are consistent, but not because of technological reasons. They just sort of match up in a kind of strange way. So think about like in Perl 5, the way you have square brackets around array composers, but you also have square brackets around subscripts. There's no reason those would have to actually be the same, but they're just kind of associated in your mind. Same thing with curly, with the braces and hash subscripting. That's kind of what we call a strange consistency. The fact that packages pop up all these different places. In the precedence table, you notice that the and the or is this and this or this and this. And that whenever the and or idea pops up, whether it's high precedence or low precedence, or in the bitwise operators, it always has the same relationship. And that's actually related to the relationship of multiplication and addition under Boolean algebra has the same relationship. So there's another one of those kind of strange consistencies that just, it might not actually mean anything for the particular spot, but it helps you remember associations as to how the language works. There's some strange consistencies in Perl 6 too, in addition to those that I listed for Perl 5. Pair notation, whether it's the arrow, the fat arrow, let's see, fat arrow, there, arrow, like that. No, it was this way for you. Okay, yeah. Chirality. Chemists are always confused. Whether it's that notation or some of you, if it's been in Perl 6 talks, you've seen the colon notation, colon, word, and then some sort of bracketed construct, optionally. That's not just for making pairs. It's used over and over again. Just for instance, I could say P6, if I say this, it's just a simple pair. It got me. Let's say it. Unexpected name parameter. Okay. See, it can be used for named parameters as well as just pairs. Now, if I do this, then it actually gives me the pair. But the same notation is used for reused for radix notations, for options on quoting constructs and s// etc. and regular expressions. So this idea, and you can extend names with these notations too. So that's a place in Perl 6 where this sort of single idea carries through syntactically, and it's not always, doesn't always mean the same thing, but it's one thing and you've learned it from many places. Another one in Perl 6 is the relationship of single vertical bar to double vertical bar. Now, in regular Perl, in regular Perl 5, you have single vertical bar, which means bitwise OR. We stole that for junctional logics, and bitwise is different. But so we have junctions, and the double vertical bar is the short circuit operator, as you know. But the same thing is true inside regular expressions now. The vertical bar evaluates an OR match in parallel, and the double vertical bar now does the short circuiting the way that Perl 5 does with a single vertical bar. So that's another consistency that has been introduced. And there are many of these that flow through the language, but I'm not going to list them all today. I actually like to talk about strange consistency in more general terms, and this will be more of a, some of you are terribly afraid I'm just going to talk about Perl all day. I want to talk about other things that interest me, and you probably already, this is the last day of the conference, you're probably already tired of Perl. So last week, my wife and I, Robert Blackwell, took us to Falling Water near Pittsburgh, and you can see it up there in the background. And Falling Water is a really interesting place. Actually, that's not me. That's someone else with a much longer mustache. Here's a better picture of the actual building, and you have these cantilevers poking out, and you notice how these terraces of the waterfall are reflected in the terraces of the building. And Frank Lloyd Wright designed this building, and he believed this is almost a postmodern idea. He believed in putting buildings in context. So this reflection of the stair steps of the waterfall is intentional, and all the horizontal lines. So there's stair steps going down to the swimming hole. All the horizontal lines. You notice the windows have horizontal treatment. All the brickwork, or all it's actually rocks, is intended to reflect all the strata around. The natural rocks look a lot like that. And so some of the decorations here, this is just a decoration over the drive. It's not functional. But you notice, again, all the horizontal lines. Well, they look angly to you, but they're horizontal. And notice another thing. If you look really carefully, he so much believed in preserving and incorporating the context. He actually, built around the tree that was there. And the stair step, there's a walkway from there up to the guest house, and notice how it also does the stair step. And it's also curved, like the curve you saw. So he has these curves as well as these stair steps all throughout the design. There's more stair stepping. Inside, okay, there's, notice particularly the shelf up at the top there. More horizontal lines, but then more of these partial circles, like the driveway, like the cutout, like many other things that are around. And cantilevered, like the actual decks that poke out over the stream. And all the desks that are in here are cantilevered. They just poke out from the wall. So he carries this idea through and through, and the same motif. You call it a motif in music or something like that. It's like a good music is always, you get to a new place, and it's always simultaneously surprising and expected. It's sort of inevitable, but also surprising at the same time. So that's what you want in something that's of an artistic nature, and I would like to think that programming languages are an artistic medium. So we get this idea of these strange consistencies that are not just symmetries. Symmetries are kind of boring. This really only pokes out cantilevered one direction. In physics, we get this idea of symmetry breaking, as in the creation of the universe, the various forces coming apart at lower energies, sort of freezing into an asymmetrical but pleasing arrangement. One of my favorite books is called The Search for the Perfect Language by Umberto Eco. And in it, he basically makes the case that there is no such thing as a perfect language. You cannot have a perfect language because there are too many things going on simultaneously that cross each other orthogonally. So if you make a language consistent in one way, it becomes unusable in other directions. So I could give examples of that, but a language needs redundancy. So this is something that over the last 15 years as we were designing Perl 6, if you go back and actually search for the word consistent or consistent or inconsistent in the logs, it pops over and over again because you'll find the argument, well, this is inconsistent. But then the counter argument will be, yeah, but if we make that consistent, then this other thing becomes inconsistent. So you have to balance these things off. The utility of language and art kind of comes from the imperfection of it. Communication really sort of relies on imperfections and redundancies and noise. The psychologists have shown that if you introduce noise to a signal, we actually perceive it better than if there isn't noise in the signal. So if you're thinking in terms of the metaphors that we build a computer language out of, all metaphors limp, as they say, but all metaphors limp forward. They make progress in your head. So the whole point of a metaphor is it's not perfect. A simile, if something is like something else, it's not there's no identity there. So it's how you line these things up in your head. When I use a metaphor or a simile, you have to actively participate in reconstructing in your head what I'm trying to communicate, and so. Metaphor requires an intelligent listener, just as falling water requires an observer. Douglas Hofstadter did a lot of stuff with this when he was writing for Scientific American and such, and talking about metamagical themas and strange loops. One of his here's a Chinese character for falling water. You can see the terraces there on the right, the cantilever there, and the waterfall on the right. Actually, what this character means is terrace. So that actually is an indication of terrace. On the right, it actually is a symbol that means hack or dig. So it's steps that are hacked out of a hill is a terrace. And we'll get to more Chinese later. But I was going on about Douglas Hofstadter has this sentence. This sentence has sofa 6 words. I actually think that's wrong. I mean, I think it's more like this sentence has sofa 4 words. This sentence has sofa so far. Well, then it would have 5 words if it was actually sofa. It's very twisty in the brain. But this idea of taking 2 contradictory concepts and looping them back on themselves to produce metaphor is also people like Owen Barfield and the other Inklings. They used to talk about the phrase "a piercing sweetness," speaking of poetry or something like that. And it's neither piercing nor is it sweet, but you kind of know what it means. It's something that really, really gets you. So, symmetry versus asymmetry is important in a lot of linguistic and artistic ways. So let's look at that a little more closely. Okay. When we were trying to decide what to have for a mascot, there was a lot of discussion. Yeah. Finally, I got fed up with it all and said, I have my own list of requirements, and these are what they are. A mascot has to be fun, cool, cute, named, lively, punnable, personal, concrete, symmetric, asymmetric, attractive, relational, metamorphic, that cuts it way down, decolorizable, shrinkable to textual icon, and shrinkable to graphical icon. So, it's Chamelea's shrinkable. That's the 32-bit, or 32 by 32 Camellia. That's the 16 by 16 that you see up on the in the what's it called? That you see on the next to the HTTP there. And of course, don't blow that up big, or it looks like that. But actually, you'll notice that we do manage to. That's actually it goes. You kind of see the antenna up the top, and maybe there's one leg here on the bottom, but we still have the Mona Lisa smile. Anyway, but movement requires symmetry breaking. You can't move all directions at once. You have to choose one direction and not another. So every time you break symmetry, you introduce a psychological movement. And so there's various things actually going on in here. I just like to explain some of the technology of the graphic here, whether or not you like butterflies. A butterfly itself, any butterfly, it's almost radially symmetrical with a four-pointed, four-lobed kind of star, except that with any butterfly, the top wings are larger than the bottom wings. And that is indicative of this forward motion idea I talked about. So that's just from nature. Another one here is that we're dealing with here is that ordinarily you'd think of this as bilaterally symmetrical, so you could draw a line down the middle and mirror image it. But there are a lot of things that break that. The obvious first thing, or maybe not so obvious, is the P6. It's amazing how subtle that is, because some people they look at this for weeks, and then they say, "Oh, there's a P and a 6 there." So that we like to be sneaky that way. If you see it now, okay. But because of that symmetry breaking and the fact that those are kind of spirals that go opposite directions, that sets up this whole other idea of spirals that do different things. So we have the two green curves that have to compensate for the holes in the P and the 6. We have other little subtle. The legs go like this, which is another kind of spiral idea. The Mona Lisa smile is a kind of spiral. Okay. And if you contrast the antenna are doing the bilateral symmetry, and on the other end we have the curves. So those are contrasting the sort of rigid symmetric thinking with the more artistic, not that artistic. Well, it's kind of a spiral. More artistic side of Camellia here. And well, let's see. What other strange symmetries are there? Okay, the use of an outline on the face is almost the same width as the antenna. Also, the outline on the eyes. That's a very cartoony idea to have a black outline. And yet the wings themselves are not really outlined. They're a black background with sort of raised patterns. So sort of contrasts the flat cartoony idea with this sort of more 3D idea. More 3D idea. I love this. I never figured out what her backside looked like, but Wendy and Liz did. Another thing that's going on about it that people have remarked on, that is all primary colors. But whether it's red, yellow, and green, like you are taught in grade school, or red, yellow, and blue, or red, yellow, and green, whatever they are. So there's some ambiguity there. Another thing is the gravity tilt that you see sometimes, and it sort of justifies the fact that the legs are falling this way. So because kind of the legs are just falling down from gravity rather than just being a deformity. And there's the black and white version. There's the textual version, and so on and so forth. So it makes me happy, even if it makes some people sad. So I also like finding patterns in Chinese characters. The left character here is butterfly, and the right character is dragonfly. You'll notice something common about those, and that's the idea of a radical. On the left is the bug radical. Well, it can mean snake too, but usually it means a bug in a sort of generic sense, creepy crawly. And if you saw the Hello World program the other day, the world had the top of, there's a tree below and the world on top. So characters break down into these subradicals. I first became interested in CJK characters 15, 16 years ago anyway. When I was doing the church webpage, this is actually a reproduction of it here. So I could do this. I could actually cut and paste the characters. Now, this may seem like nothing, but back in that time period, all Chinese characters, at least in the US, were GIF images, unless they were GIF images. I think they were GIF images. And so you couldn't cut and paste them in Unicode. And so I spent about 2 hours with the big, heavy first volume of Unicode 1.0, looking up these characters, painfully. Because here's the problem. Okay, you have a simple one like this. You see, it's third at the end. By the way, this says, proclaim holy meeting, new birth life assembly, is how that's translated. That's the Chinese name for our church. This one, the birth or life one, is just a radical on its own. You can just look that up if you can find it in the book. But it gets a little more complicated with this. This character has 3 parts. Top left is ear, mouth, and on the bottom there, it can mean jade or a jewel or a ball orb. I call it orb. But you don't know this if you're first looking it up. So how do you look it up? Well, okay. That's not the one I want. I want that one. Okay. Well, I can look it up. And I have a little program here that I've been developing. So I can say ear.top left, mouth.top right. And there it is. Bink. And we'll talk more about that. Here's a simple radical that means big. I first became interested in learning Japanese the first time I went to Kyoto in 2001 at a conference there. It's the first time I met Mats too. And so on the side of the hill there, they have a big. They have this character on the side of the hill. And just last year, Lori and I went there and lucked out. It was the one day of the year that they actually light this up with bonfires on the side of the hill. And it's a festival they have, and they have all these symbols around the hills around Kyoto. So we got lucky and actually saw the lit up version of it. But it's a big. It's a pun. But there's lots of characters that are easy to confuse. And you have to kind of learn to tell them apart if you're going to read Chinese characters. So big tree, there's fairly obvious difference that there's a tree trunk, and it kind of looks like a tree. The big kind of looks like a big guy doing this, right? So there's various mnemonics you can put in your head to remember these things. Some are more subtle. The left character there means spirit. The right one with a little tick on I think of it as the tail on a coat or something, means clothes. Clothes. Clothing. This one's even more subtle. Does it look the same to you? Almost the same, yes. The left one means earth, and the right one, that's an interesting character. We'll get to that. It is usually translated these days as scholar. Okay, how about these two? The left one is moon, and the right one is meat, but there is no difference. Occasionally you get lucky, and they will write the meat with kind of a diagonal blips in there, but usually not, especially when it's combined with other things. So here's a slightly more complicated. This is actually in Unicode. This is the character with the most strokes, which is 64. There's more than one definition of most complicated, but we'll get to that. This seems pretty complicated, but in actual fact, it's made up of 4 dragon characters, all crammed together. So that's the actual dragon character. Now, the interesting thing about Chinese characters is they don't care about the aspect ratio. So if you reuse one of these characters as a radical in a larger character, the outer character is always square, because then you can write it equally vertically or horizontally. But the subradicals will squish. So you see the dragon squished this way up here and squished this way. Same with tree is squished this way and that way. Okay, well, here's a different definition of most complicated. This says biang biang mian. Got that? That's biang 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 biang. I got to get the tone right. Biang biang. Noodles. Though that's also the character for face. Interestingly, there's the Japanese actually differentiated noodle and face into 2 different characters, but the Chinese put them together. Well, what can you actually figure out what's inside that? Well, I mean, there's sort of something obvious on the outside that looks like a swash, and then there's this kind of blur in the middle, right? If I was Damien, I'd actually blur it out or put wah 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 wah. And here's what the character looks like. I mean, you see some parts that look a little familiar to you. At least right in here, kind of on the left, you'll notice there's a moon, unless it's meat. What this actually is a kind of noodles that this is a picture of those noodles. Here's a different version of the same character written a little more sloppily. They're actually using a few different subradicals here. They claim that the the 4 dragons, each of those dragons is 16 strokes, and so altogether that's 64 strokes. This character they list as 58 strokes, but this has extra 3 little dots on the thread thingies there on both sides, and they use a different thing for knife on the right with 2 extra strokes, which makes 8 more strokes. So that's actually, as written here, has more strokes than 4 dragons. But it's not a Unicode character. They haven't decided to put it in. I guess it's too commercial or something. So this shall show you, first you draw a roof, and you put an 8 under that, and that makes whole. Then you draw words in the middle. Then you draw tiny on the left and tiny on the right. And then you draw long here, and you also draw long over there. I keep doing this backwards from you, don't I? And then you draw this in the middle, which is horse, and then heart, and then moon or meat, and then knife, and then walk or movement around the whole thing. What does it mean? Well, it means noodles. So here's a non-moving version. Notice how they very carefully lined up the bars on the horse and the long characters there. They didn't have to do that. But that's one of these strange consistencies that you can get. If you look at the horse character, actually we'll have a better example of the horse, I think. Here it is kind of in boldface. Again, here they've added the 3 extra things, but they have the regular knife on the right. But you can kind of see that it's the same character. Now here's another interesting thing. Chinese has, in mainland China, they use a system of simplified Chinese radicals. So that still means long, and that still means horse. But it's a lot simpler there. But you'll notice up at the top, the words is still words. That's a picture of a mouth with words coming out of it, in case you didn't get the metaphor. There actually is a simplified character for words too, but they didn't use it here. So don't expect consistency. A lot of people fall into the trap of thinking, those commies in Russia, they made everybody use these simple, especially if you're in Taiwan, you think this way. They made everyone use the simplified characters. We should use the traditional characters. But the fact is, simplification has been an ongoing process over centuries, and some of these are just derived from handwriting. So it's kind of not surprising that many characters, when they get copied, they get the short form written in. So that was Byang, Mian. Now, Mian, the noodles, you're more familiar in Japanese perhaps with men. If you've had ramen, okay, the men of that is noodles. Same idea. But they borrowed it way back when from Chinese, and so the pronunciation is different in Japanese. Okay, so here's the horse character, both in traditional and simplified form. And in the traditional form, you can actually kind of see the 4 legs and the tail hanging down here. And up on top, that is the mane flowing, the head and the mane flowing that way. And you see they believed in laziness and patience and hubris here, so they just put a line for the 4 legs. Okay. But these are what you call pictograms, and a large subset, especially the base radicals, are pictograms originally. They were pictures drawn of the object in question. Now, I told you that this one upper left here, notice the top line is longer. It's not Earth, it's scholar or warrior. Those are the current meanings of it. But in actual fact, much of the characters in Chinese were created by dirty old men. they didn't really let the women write. So some of it, is essentially pornographic. The upper left one is really the masculine organ of reproduction, and the right one is actually a picture of a prostitute showing her wares, but it's translated trade these days. But you know what the oldest trade was. So I mean, there's a lot of these characters that they're quite earthy, even if they aren't quite Earth. This one up here on the left, it has two radicals. The right-hand one is a picture of a needle, so it means sharp. The left-hand one is corpse or body or butt or bottom, and hole, so literally asshole. And so that's pain in the butt. Though in my database I just call it PITA, P-I-T-A. I can prove it. There it is, right there. Okay. And the lower right one, bottom rice, that's shit. So, slightly more uplifting. I mean, we have dragon. You see, how would you look this up? I mean, what is this? I mean, it looks like the stand radical and the moon or meat, and something weird on the right. And we have this problem in Chinese that the dictionaries, they only have a few, like 100 or 200, depending on how you count, base radicals, and everything else is just random shapes. They just you don't have names for them. You don't have an identity in your head. And I wanted to give them an identity, so this is how I got to this project. So, I mean, if you wanted to look this up and you didn't know it was dragon, you'd like a program that you can say, there's something that looks like stand on the left top and something that looks like meat on the left bottom. And there's dragon. So you see how there's other similar characters. So you see there's this stand and meat in other characters too. So maybe that's actually does that. Well, you can actually determine that I called that V-dragon here. It's a variant of dragon. Stand on top and meat on the bottom. So anyway, these things decompose like that. The thing on the right actually is a picture of back spikes. This is another actual pictograph. The thing on the left is what we ended up with head. That's the head of it, and the sort of breast, the meat of the chest of it, and the spikes, the Godzilla spikes down the back is the right-hand side there. A lot of these characters got turned over 90 degrees over the years. This one down here is wing, and you kind of see it looks like two wings, like two angel wings, or a butterfly in profile. Okay. Now, at this point, I'd like to show you a little bit of what's actually going on here. There are these pictographs, and there are also a lot of what are called logographs, and that are actually, we think of Chinese, as Westerners, we think of Chinese as all pictographs, but they actually, a lot of the characters are phonetic. They have a part which gives the meaning of it, but they also have another part which gives the pronunciation, and that will often be a pun. So, for instance, here's a character called that I call between. It actually is originally a picture of a clam shell with water flowing through it, as clams do. But you picture the clam opening up like the manipulosity and whip aptitude diagram, but it means kind of between, and it's pronounced kai. Well, jie in Chinese, but it's consistent in either case. But if you look up here a way, well, I'll just do it. Between on the bottom and field on the top. Okay, now notice this is also pronounced kai or jie. It's a descending tone, jie. Now this is field on the top and between on the bottom. So you want to have this idea of a boundary. So you put a field out there, and that's kind of about boundaries because you have fields and there's something between them. And the between idea is adding to the meaning of between fields, but it's also supplying the pronunciation of the character. And many characters work like this, that part of the character will give you, that's a little hard to see, that's better to see. Part of the character gives you the pronunciation, part of it gives just semantic meaning. Okay, and we've already seen that there's a lot of duplication with the four dragon character. Four-dot-dragon is the one we showed, but there's also two-dot-dragon. So you could think of the four-dragon as two dragons on top of each other, and they add various plural-ish meanings or abstract meanings. So, for instance, forest is two trees, but woods is three trees. So if you have three trees, they're more closely packed and they're smaller. So it's kind of like a woods of little trees. And if you have two trees, they're big trees. So it's a forest. Things like that. So you get those kind of strange things going on in this database. So I was starting to fall in love with these characters, and I'd look at a character like this, and as it was with most of you, I'd see just sort of mush. You just can't analyze it in your head because you don't have names for anything. So I decided to create a text file, and so why don't we do this? Okay, so I have some notes here at the front. The format of it is anything that is not a hex code is a comment. So all that's commentary at the beginning. I have some completely abstract things and some made-up characters. But the first real character in normal base plane of Unicode is character 1, single stroke. I call it horizontal bar, so because I also have a vertical bar, for instance. And it goes up in complexity from there. And so I created this database with the actually, there's various Chinese definitions brought in here. I think every now and then you'll see, okay, well, this is actually a Japanese definition. You can tell that I was started out with Japanese because I actually have inlined the Japanese definitions and don't have the inline Chinese versions. But I've been trying to make it, more egalitarian since generalizing to all the CJK characters. Okay, so whenever I want to declare a new term, that's like a my. It declares that is a new symbol, and that is the name for that character. The radicals are all marked radical, and so there's enter, which looks a lot like person but isn't. There's 8. So if I just scan for radical, I get lots and lots of radicals. See, there's the earth and the hunk. I call it hunk because it's, it's the symbol of virility. They call it scholar. I suppose some scholars are hunks. Child. There's like, couple hundred radicals here. Now, there are variants of them, as we've seen with horse. So I distinguish the actual radical names with upper and lower case from the semantic idea of them, which is all uppercase. So if I were to say, so if I say lame, well, let's just get the, well, that's all of them, isn't it? I want lame radical. There we go. There's one lame. There's another lame. This is getting pretty lame. But I can say lame this way, and all of the lame radicals should pop out. Okay, and there's a bunch of them. More than most. Many of them, mountain radical. There's only one. But jar looks like it has a mountain in it, so it listed that too, but that's a different radical. So anyway, they got all these radicals, 200 or so. That's not nearly enough. It turns out if you name everything that has any repeating characters in, and you cut it off at about 4 or 5 repeats, then in the base plane of Unicode, there's about 3,000 different symbols that I've given names to. If you add in the extensions up in the upper planes, there's another 3,000 symbols. But most of those are actually just other characters that already exist. So, and we don't even know, a lot of these are just using names. You can't even look up their meaning. So I don't actually know what 4 dragons means. Let me show you how this works. So here I'm way down in extension E. It is, in fact, you notice I don't even have most of the characters here. They're just hex codes. So I'm sort of working blind, but what I actually have here is the Unicode PDF file that goes with it. So E2 here, whoops, that's not what I want. Okay, so 0E2, you can see over here is tree on the left. Actually, it's tree and boat on the left and boat an inch on the right. So there's an ambiguity in how you parse that. It has three parts, but you can view it as 2 and 1 or 1 and 2. It's probably 1 and 2, but you might look it up either way. So I write it both ways. And it intuits from that, however, because I can actually say tree left boat dot center. What was it on the right? Inch or measure on the right, and it should actually find that. It still doesn't have the glyph. Some of those fonts are actually proprietary, and you have to pay money to get the fonts. So I just used the ones the Unicode Consortium gave here. How I add this. So E3 is a tree on the left, tree on the left, tree on the left, bottom tree. Okay, and this tree is on the bottom. At there. So E3. Okay, claw on the right top and build up on the right. See, part of the reason I did this was actually to learn it. I thought about actually Anna going out and doing analysis on the fonts and have it figure out the statistics, but I mean that's no fun. That's like aiming your camera at a Chinese character, and it tells you what it means, but it doesn't tell you how recognize it yourself. I wanted to learn to recognize these myself and actually have these. So now what I do is I have if I type Control L here, it looks it up, and it says, oh, there is a character called claw buildup that already exists and already has a name. So it just inserts the name there, and I'm done. Notice it also adds up the stroke count from the other two characters and slips it in there in place of the 99, which means I don't know yet. I can look up things by stroke number. So if I look for, things with tree and 13 strokes, I'll just get the ones with 13 strokes. But stroke count is not really, you have to use stroke counts if you're looking up in a real dictionary, a paper dictionary, but this is easier. Maybe not as easy. You're pointing your Google Translate at it or whatever it is. E4. So tree on the left. Oh, that's a strange mortar. What is that? That's it's mortar on the top and out on the bottom. No, mortar. There's a weed there. And we don't actually have one. Mortar on the outside and V-bar on the inside. Don't have that either. So we actually have to describe this one. So I say mortar dot right top outside vertical bar dot right top inside, and unless it's center, I might have called it center. Okay, and this is out on the right bottom, and then let's try that. It might be center and anti-center. Oh, there it is. Yeah, that's how I did it. I classified it as center and anti-center. So there's the character. It already has an entry here. Here's the entry for it. You notice the name is just the two subnames pasted together. I have no idea what it means. All I'm trying to come up with is unique identifiers for every character, or every radical that's used in a different character. So anyway, so we looked that up successfully, and this is how it goes, and so on. Tree on the left, or E5. Yeah, that was the one that was tree on the bottom. I miscounted here. That one's tree on the left. Okay. Well, this one is fun because improvise on the top left and strike on the top right. If you improvise a strike, so here's an entry. I need a new entry. Of course, I have a key code for that. So it automatically glues them together. If I then go back to the original entry, I can have another key code, just turn that one into the one I just made, and I can double check it and it doesn't change the stroke count, so it actually looked it up. So that's how I make progress on this. And then I run a program called splitrads. Actually, I just type make. And what splitrads does, slowly, it goes out and creates two files, well, more than two files. The main file it creates is called all, down in CJK rads, all. And you notice what it actually does, whether it's these synthetic characters that don't really exist in Unicode or something that's more complicated. Let's look at, I actually have Byung in here. It expands from, here's the original definition. From that, it expands out to everything you might ever look it up by. So here's the original, whoops, it's too big to list. Okay, everything down to this square bracket over here, and this is all the expansions that you might, if you don't recognize the actual radicals, you can do subradicals and subradicals. So it says there, there's a sleeves that is inside, middle, bottom, anti-center, bottom, bottom. Down here. So if I put that in, it would actually find this character. So it's doing that. The other thing it's actually doing is going out and in CJ, I can't write it, K-rads, vec is building a bunch of bit vectors for every one of the base symbols. And these are binary files, so if I, OD, you're gonna, this is a bitmap of all of the lines in that file that contain fire somewhere. So this program I'm using over here called rad, because it looks up by radical, then takes and I have it in both Perl 5 and Perl 6. The Perl 5 one is faster and buggierless. So that's the one I'm doing here, but okay. So it's just going out here, and what it does is after it processes all the switches here, reads in any aliases that I'm always changing the names of these things as I learn more about Chinese. So I put the old name as alias, and then if I don't remember the new name, I can put the old name and look it up. And this is the thing that actually does look up. Notice it starts off with a vector that's all set, and then it ends in, it basically goes in and ends in all of the bits that we have from the vector file. So it takes all the symbols that it knows you're looking up by, adds them all together, and it only has to look at those lines. That's what makes it fast. It's a neat trick, but it's just an optimization, and then it looks them up. And the Perl 6 one is, it's a little fancier. It uses give and when on the switch statements, but essentially it's doing the same thing. Okay. Well, I need to wrap up here pretty soon. Before I forget, there was actually a thing I noticed here, and that is that we had hole on the top and heart on the bottom, and that should actually be combined into two, because I think rad, hole on the top, hole on the top, and what do I say, heart on the bottom. There actually is a character for that out there. It's out in the extension area, but so if I find that character, add whole heart, come back here, whole heart on the inside, and it's anti-middle, so top and bottom. Okay, that means the same thing, but I can look it up by whole heart now. Okay, well, enough of that. Saw this character Wing before. It's one of my favorite characters. It's used in the the character learn is wings and white on the bottom. But the reason the wings got that meaning is because little birds have to learn how to fly, and so fly. I don't know. Maybe it didn't get it for that reason, but it's a cool character because it actually looks like wings. And another thing that kind of looks like wings is 7.7. You might know, why is he saying this? Well, one of the greatest marketing strokes of modern times is this. Boeing 707. I've ridden on all of these planes. There also is a 717. Well, there's two different 717s. One was a bomber. I have never ridden on that. There is a 717 that was a rebranded McDonnell Douglas MD-95. I might have ridden on one of those. I'm not counting it. But of these things, these are still in service. And, you know, Boeing's a great company, so is Airbus. I mean, you could do the same thing with, you know, Airbus models here. You know, and we think, well, you know, do they fight inside Boeing between these different model lines? Well, you know, they're probably struggling for resources. There's some good-natured tussling inside, but you know, outside, Boeing is the unified front. So, you know, we have different models of Perl too that we've had over the years, and currently, you know, these are the two models in service. Actually, you can compile Perl 717. It's still, somebody's been keeping it up to date. So, yeah, but the Perl brand is Perl. It's not the 750. It's not the model number. It's not the, you know, and I don't think Perl 6 is necessarily the Dreamliner yet. I'd like to think so, but has yet to be proven. So, you know, what does Perl mean? Is it the model of airplane, or is it the group of people that are represented by you here today? Well, I think you know my answer to that. It's you guys. You know, we are Perl, more than any particular branch of the technology, any particular model number. So whether you are big or small, whether you are feminine or masculine or some mixture thereof, you are a person, and you are a member of a tribe, a clan, a family. I think it's this is one of the neater characters, and it represents us because if you look carefully, you can kind of make out a P and an E and an R and an L there. I mean, doesn't that spell Perl? Yeah. I'll help you. Thanks for listening.